Last lesson, we watched the same model. Score 14 out of 14 with context and 4.5 without it. The gap wasn't the prompt, it was just an operating environment. This lesson, we iterate a project context. We will build a shared context layer, .github and the docs folder. So every Copilot service starts from the same ground truth. By the end, you will know exactly which file belong in each folder and how to keep them clean enough that the model actually reads them. This is what something called as discoverability of context as well. This lesson boils down on one idea, .github. That tells the assistant how to behave. Docs tell what to know. If either half missing, the assistant can still sound competent while missing your repo's actual rules. As of early 2026, this particular behavior has cited 7 services: always on instruction, path scope, instruction files, prompt pile, custom agent, agent skill, hooks, MCT and server config, plus agent.md, and if you are in the cloud, then cloud.md for the cross-tool support. This particular example, intentionally narrow. We are not asking a model to invent a new feature. We are asking to tighten existing modification preference route while keeping the owner-only right, delegated session, blocking, audit logging, and centralized forbidden error intact. So before we get into the workflow here, let's see how it works on Visual Studio Code. It's one of the very interesting area of this. So let me go back to Visual Studio Code and let's dive there. So now we are in the Visual Studio Code. It's a similar example like parse, what we saw in 0.1, but it was with and without. This will be very interesting. We have curated a simple but a very powerful Copilot instruction.md. Now, however, you can see this Copilot instruction.md is just 37 lines. But there are a lot of references been given as a path, as a type. What we would like to see is when we provide a Copilot input, and then we start so we don't waste a lot of time, it will be just, we can run using the util.py demo, and you can download this example from the GitHub code and just try by yourself. So what it will do, it has deleted the source, it has recreated source, the logs are working. We would be expecting only this particular file out of this source that updates. It's a quite large project in compared to not enterprise large, but it's a decent large project, around 100 to 150 files, and a database as well, and a front end too. And based on that, the prompt we are passing here, we anticipate that just particular file should change. And along with the file, we are expecting this pattern to be observed. Also, we will be looking for when the assessment will be created. So this is the assessment from the previous run. And this tells when this particular program was run, there we go, how it actually read and at what point. The first turn actually got it from our index and then index the important area that we highlighted there. It worked like a pin. And then after the next step, the session start going on other files and only one search as a block pattern, and in this order with a very limited context, it was able to achieve it. So now I think our process has been completed using the GitHub Copilot CLI. And if we see expected pattern was this, expected file was this, and change file was this. And if we see the demo patch, it exactly arrived what we were anticipating. I have tried this example without even. The same way it bloated around 300 to 400 line. It wasn't able to keep it up. But if we carefully see here with the Copilot long, and if you analyze, it has actually used less than 20,000 tokens, which is a perfect example that how effective our context management can be and how effectively we can apply to precision engineering. So it has completed the CLI, and let's see the assessment. I think assessment remains same. It always update afterwards. So is there any update in it? No, it was pretty much. And then I got my internal validation that does it pass scoreboard. I was to highlight this particular assessment criteria as well. Whenever we are building and curating any context or project, it's not just a job to create some documents and using even AI or anywhere. The context engineering and context creation or curation is actually a scientific process. We need to have assessment, we need to have validation tools, and we need to actually test it against actual coding agent. By seeing that, whatever are we doing it, is it picking up the right scenario and is it passing the right scenario? Any project that I do, I generally have around 5 to 7 different very validation criteria where I assess against 10 to 15 different test case scenarios where I'm ensuring that my context discovery is at least reaching about 95% on a desired scale. And that provides me a confident ground before I actually release the context to broader team. The context engineering is really an art, and that art actually leads to a successful AI assisted programming for not just one person or two person, but the whole team. It's really essential and absolutely cannot be disposed as a requirement in any case. So let's go back on our slides and let's understand where we left there. Right, so we are back here. So this is what happened in a broad sense. The task extracted the shared helper from the 3 roots because the repo already has the rules and architecture document available. But if you have remember, when I show you the GitHub instruction, the way it was creating the graph by providing a unique path patterns. And that unique path patterns actually, instead of a linear context, created a graph where the AI assisted tooling can actually traverse very effectively by not bloating the memory and by not bloating the context, and that will eventually lead to least or no hallucination. The biggest challenge, even with the greater context, is if context discoverability goes beyond 100%, which means your 100% is your benchmark, that is a minimum context that you would like to be discovered for a particular request. It's better to target 90 than to target 150. Because generally, in my opinion, when we target the higher end of the context discovery, so that means 50% extra context has been passed, which is not necessary. Generally, it leads to hallucination and bad decision by AI. While if we target the context below 90 or just around 90, the AI can come in an iterative loop and actually target the missing context that it is looking for. So always important for context engineering that where to target our context discovery. And this is the exact example to show that what kind of various tests you should build to validate the context you develop. So let's go back on the next point. On this, the response agent fire the 8 parallel tools. That is the context layer doing its job. Already knows literally the source of truth from the file. Reads before making any changes. We make sure that everything that required in order to understand the common value of it or principle that has been done. It reads basically 10 discovery before the first try and then find 3 helper extraction. How to rewrite 3 rules without adding a new layer. And this is exactly what correlate what we discussed. Targeting 90% and then let the AI come back for remaining 10%. If we go below 75 or 60%, then AI will actually make the guesswork. And if we go above 120 or 140% as a target, then definitely you can assure a greater sense of hallucination and more AI slop will be developed. But the sweet spot is 90. 90 to 110 is the best sweet spot you can target. But even on that rate, I would consider target towards the lower end of it. The only one file get modified and the session end, storing the learned pattern in memory. That output isn't just one off patch, it's a reusable context for the next run. And that's the most important. Here is a takeaway. Good context is curated, not dumped. Don't duplicate limiters already enforced. Don't paste the whole documents. Don't build one giant rule file. Don't leave the stale behind. Write only what changed the run. One quick tip that I probably give everyone is a try init / command in VS Copilot chat. It can generate a starter pack. But after that, take over and make sure that you curate the context you look for. Do not just rely on AI generated. Generally, I have found it is highly bloated content. Use it as a bootstrap and then keep refining. Keep refining, keep practicing on context and validate and make sure that your at least 80 to 90% cases has the context discovery somewhere between 90 to 95%. And that's the most important exercise before passing the context into actual project bootstrapping. Before that point, I would never recommend a project should start and then keep maintaining the context. So, very simple. Context is where you will make or break project. That's wrap lesson 2. Now I want to hear from you. What's the biggest challenge that you had curating the context for AI tools? Is it the stall doc, or too many rules, or not knowing where to start? Share your thought, doubt, or questions in the comment section below. We'll be selecting the best comment to join in live sessions. In live sessions, we exactly talk this kind of a learning and we share the learning. It's one of the most valuable way to actually explore and master this art of context. Finally, make sure you hit a subscribe and turn on those notifications so lessons reach your timeline the second they drop. Thanks for watching and I'll see you in.